Hello, my name is Fabian, and I'm going to talk about the NoRDF project. I'm sorry, we don't have any fancy acronym. This is because we didn't expect the project to get accepted, and so we didn't put much effort into this. But yeah, so this project is all about knowledge bases. So what is a knowledge base? It is basically a graph where the nodes are entities and the edges are relations between these entities. So here you see my favorite singer, Elvis Presley, and he was born in 1935, so we have an edge there, and then he's a singer, and every singer is a person. Yeah, and you can think of a knowledge base in a first approximation as such a graph. So why would you want to think of such a knowledge base? Because they are super popular with lots of applications. So, for example, the Siri or these personal assistants on your phone, they use a knowledge base. So we know that Apple, for example, uses the Wikidata knowledge base. These other assistants like Amazon Echo, for example, uses a knowledge base that they built by themselves. And IBM Watson, which is a very popular project by IBM and is used for biomedical purposes as well, uses also a knowledge base. So you see that there is a wide spectrum of applications, not just the fun part in your pocket, but also serious stuff like determining which proteins relate to cancer, right, which we must care about. So all these applications are based on knowledge bases, so in one form or another they have this type of graph behind them. So what's in a knowledge base? Oh, there are plenty of knowledge bases actually. So there are academic projects, Yago. I need to read a message from my sponsor. So we have a new version of the Yago knowledge base available at this URL. Please go check it out. DBpedia, BabelNet, NEL, Wikidata, I mentioned TextRunner, like lots of academic projects, and there are also industrial projects. So all major players in the area build their own knowledge base. Google does it, Microsoft, eBay, Facebook, IBM, they all build knowledge bases. Yeah, so it's a super hypey thing. So what's in a knowledge base? Well, essentially binary facts or triples, as we call them, in a format that is called NoRDF, sorry, that's the project. The format is called RDF, the Resource Description Format. And Johanna mentioned that briefly already. So here, for example, you have a person in the Yago knowledge base, Andrew Wakefield, and he is linked to the class of humans because it's a human. Every human is a person. Not every person is a human. Yeah, you see, because there are like fictitious entities, yeah, that can be people but not humans. And then you see in the star shape around what we know about this guy. Yeah, he was a film director, and he's British, and he studied at the Imperial College, and he was born in Eton, and so on. Yeah, what else? First name Andrew. Yeah, okay. So, yeah, interesting. But do you know who this guy actually was? Do you have any idea? I mean, just raise your hand or just speak. Do you know who this guy was?
Yeah. Autism and vaccine, yeah, autism and vaccine, yeah.
Exactly. This is the guy who postulated the link between vaccines and autism, yeah, which led to all this autism, or these vaccine people who don't like vaccines, and these are big problems, right? And the thing is, you can't see this at all from the knowledge graph. Yeah, here is the full story. So in February 1998, this guy published a paper in the medical journal The Lancet, which reported on 12 children, talk about sample size, with developmental disorders. The parents were said to have linked the start of the symptoms to vaccinations. You see, the parents were said to have linked, right? The resulting controversy became the biggest science story of 2002. As a result, vaccination rates dropped sharply. In 2011, the British medical journal detailed how Wakefield had faked some of the data behind the original article. You see, so there was some story, right? And this is leading to huge problems in the US, but also in Europe, right? People don't take vaccines anymore because they think they heard somebody said it causes autism, yeah? And this is actually causing problems. And what we see here, like what we care about, is these beliefs, these claims, these events, these reasons, like this is supposed to lead to this story, like he did this, and then he published this, and other people read it, and then they rebuked the story, and these falsifications, but none of this is actually in the knowledge base. Yeah, if you go back here, yeah, he's a film director, he's a British, Yeah, right. None of this is there. Right? So what we care about is actually not in the knowledge base. Yeah, when you go to a bar and you talk about you read something in a newspaper about this guy, you're not going to say, yeah, and he studied at Eton College, and he was born in Lancaster. No, you don't care. Yeah. So this guy postulated this link, and this is actually not there in the knowledge base. Yeah? So you see, we have a problem. And as by coincidence, this is the problem that we want to solve in the project. So we want to go beyond triples, beyond this format of RDF. This is why it's called NoRDF. And we want to represent and extract exactly these types of information. So we want to do two things. We want to extract this knowledge, build it up from natural language text. Think of news articles or encyclopedia articles. We want to read this in an automated way, and we want to build up this knowledge, and we want to reason on it. We want to represent it, and we want to reason on it. So these are the two pillars of the project, and I'm going to talk about these two now. So what is possible already in information extraction is lots of things. So here are different systems that can take a natural language text or natural language sentence and produce some structured representation of it. So for example, the sentence Andrew Wakefield published in The Lancet in 1998, it is possible using these techniques to extract that this is a publication event, there is an author, there is a venue, there is a time. Yeah, we can do this. And we can even link it to a knowledge base such as, for example, Yago. Yeah. So this is possible thanks to these techniques: Fred, K-Parser, document spanners, Clausy, Stuffy, OpenIE, HighLife, and classical slot filters. This is possible. But what these things cannot do is treating anything like the following sentence. Wakefield published the paper that reported on children. Their parents were said to have linked blah blah. The resulting controversy caused vaccination rates to fall. So what usual systems would extract here is that Wakefield published a paper, yeah? Which is nice, yeah? But it doesn't capture at all what the sentence is actually saying. Yeah? So what we want is something like this green representation here, where we have like the publication, the guy who published it, with a claim. The claim is done by the parents of the children that the publication is about, and the claim claims a link between the symptoms and the vaccination, which caused, you see we have causal relationships here, a rate change of vaccination. Well, this is what we want. So we need, for this cross-sentence analysis, current systems take sentence individually. Yeah? So you have one sentence, another sentence, and then they cut them. And if the second sentence refers to the first one with the pronoun, then the link is lost. Yeah? Which means if you read a biography on Wikipedia, it starts with like, Andrew Wakefield was a scientist, he blah, 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 and everything that follows is cut off. Yeah? Because the systems don't usually do the enough resolution. Yeah? We need standardized types of frames, relationships between events like causation, negation, hypothetical stances. That is, if this guy says something, it doesn't have to become part of the real world, and so on. Yeah? So if you know a system that can do it, yeah, type it here or let me know. So I'm really interested in this. For reasoning, so likewise, we have plenty of approaches. If you're a bit in the domain, you might have heard of frames, JSON. Johanna talked about this, complex objects or object relational databases. And there are like so many more approaches, RDFS, OL, description logic, like there's an entire logic machinery that can do plenty of these things. But they all have a drawback that either they are undecidable or they cannot represent what we would need for our use cases. Yeah? They cannot say like all clients believe that the company delivers a good service. Yeah, they can't say this. Or if they can say it, they are undecidable. The loss of value on the stock market happened because the public learned of a fraudulent activity by the company. Yeah, this, they can't do it. Or Mary believes everything Paul says X, therefore Mary believes X. Yeah, this, they can't do it, or if they can, they are undecidable. Yeah, so what we would need is a type of simple logic inside a context, just simple things. Yeah, I believe this, and I believe A causes B, therefore I believe B. Yeah, something like this. And a very simple logic about context. So if Mary believes everything she reads, then we want to express it this way. Yeah. I don't know how to do this. Yeah, this is the project just started 9 days ago officially, and we haven't even signed the contract. But if you have any idea of how to do it, please just talk to me. Yeah, I'm interested in this. So why am I interested in this? Because the applications go far beyond this example of Andrew Wakefield. Yeah, you can see that this helps the analysis of fake news because you want to read an article, you want to represent what is being argued for without making that part of reality. You could analyze the e-reputation of a company. So somebody says something about the company and believes something because of something else, and you're plainly in the frame of the project. You want to model controversies, like, I don't know, the election of the United States or the, well, there are plenty of controversial things that I want to get into here. So all these stories require modeling the arguments. Why? Because if you want to refute an argument, you first need to understand that argument. We usually skip the step. We usually start refuting some argument without understanding it first. Plenty of more applications. Flagging fraudulent activity, modeling processes. You see, like, if you take a IKEA chair, first do this, then do this, then do this. It's a sequence of events. We have a sequence. Smarter chatbots that don't forget what you said 2 lines back. Understanding legal text. This is a big thing. Some regulations or something. So it is no surprise then that plenty of companies are interested in this, and our project is sponsored by lots of partners. We work with EDF, Schlumberger, BPCE, and Convertio, and we are sponsored also, as all chairs today, by the ANR and by my school, Télécom. The project runs for 4 years, and well, who's in there? Well, that's me. I'm at Télécom Paris in the DIG team. So the team works on anything that has to do with data, intelligence, and graphs, most notably knowledge bases, but not only. And we work together with Chloé Clavel, who is a professor also at Télécom Paris in a neighboring team, and she works on sentiment analysis and effective computing. So she's interested in anything that has to do with expressing opinions about something. And we have already hired 3 people, a postdoc and 2 students, but we're still hiring. So in case you're bored with your own project, so you can consider looking at this one. So we are still looking for 2 PhD students and a postdoc, and if you want to join our team, I invite you to have a look at our webpage. Thank you.
Question maybe? Yeah.
So on your slide about the interaction on this sentence, so it's like that. So it's a challenge of information extraction on that sentence, so it gets converted doesn't get converted to graph. But if I understand well, this is not a problem of the graph, and hence is not a problem of RDF. Am I right or not? It's a problem with information extraction, so the construction of the graph, but not the structure, the classes of graph that you could construct.
Yes, there are different ways to see this. So this is the extraction mechanism, and RDF is the knowledge representation, that is the graph. Now, most people converge on RDF on the graph, and they don't question this. And we can stay with this. It's one option. And then it's indeed, as you say, a problem of information extraction, of constructing that graph. Then there's a different question. Is that graph what we want? Joanna would say yes, but yeah, maybe there are different techniques that we rather need instead of graphs, right? I don't know.
Yeah. I think you're more hopeful with reasoning than I am. So if you want to, I don't have this reasoning ambition. I lost hope that people want to understand the other person's argument before attacking it. So I will, I'm settling for less. I'm just settling for being able to prove that something was written somewhere, where, by whom, and when. Sorry for it.
Well, that's fantastic because it shows that the projects are complementary, and I should have mentioned it. So we plan to work together, of course. So there are like several projects in the area, Joanna, mine, and I think there are 2 others that are going to be presented today, and we know each other, and we're going to work together on this.